Hello friends, welcome to Truth of Physics. Today in this video, I will discuss a general method of how you can draw the wave function. Suppose, first I am going to discuss what I am going to talk in today's video. Now for an example, let us take the example of a infinite square well. We know that for infinite square well, suppose for symmetric well, asymmetric one, suppose this is 0 to a, this length. We know that for ground state energy, the wave function looks like this. This is the psi. This is the positive y-axis. This is the x-axis. This is a point. This is origin, right? And for fast excited state, it will look like this. That means you can using today's lecture, or using the formalism of today's lecture, you can easily predict that whenever there is the wave function in the positive y-axis, the wave function, the form of the wave function will always be equal, always be this. The form of the wave function above will never be like this. This will never happen whenever there is the wave function is in the positive y direction, right? You can see that this is the first state wave function, this, and this is the ground state wave function, but both of them have a definite shape like this. This will not be like this. And similarly, for negative y direction, the wave function looks like this. That will not be, never be this in the negative direction. So this general method I am going to discuss in today's video. Not only square well potential, you can draw the wave function of any kind using this general formalism. So let's begin. The Schrodinger's wave equation minus h square over 2m d2 psi over dx square plus v psi, which is equals to e psi, right? Now if we just rearrange this thing, then d2 psi over dx square will be equals to e minus v, means minus of e minus v, and there will be 2m, right? Minus 2m this divided by h square, right? So this thing, right? Now let us consider some cases. Case 1, when e minus v is less than 0, that means this quantity is negative. That means this total quantity on the RHS will be positive. That means LHS will be also positive. That means LHS will be positive. That means d2 psi, the double derivative over dx square, will be positive. Now this, what this denotes? This denotes just that whenever psi is greater than 0, then the form of the psi, right, when we draw the psi, the form of the psi must have a minima, right? As psi is greater than 0 and d2 psi, that is a double derivative, is greater than 0. So using the concept of mathematics, you can say that maximum minima, concept of maximum minima, you can say that there the psi will have a minima, right? Psi will have a minima in that region, in this region. That means if we plot psi here in the y-axis, that means upper region in the above the x plane, the x-axis, above the x-axis, there will be whatever may be the form of psi, that means whatever may be psi, but there must be minima, right? That means it will have a minima like this. And what will happen in negative? That means below the x-axis, whenever psi is negative, then there will be a maxima, right? So it will have a maxima in the lower. That means the wave function will look like this, right? It will not happen that in the above the x-axis, the wave function will look like this. That means it will not have a maxima. And okay, this is case number 1. Now let us discuss case number 2. What will happen when e minus v is greater than 0? Now our case 2, when e minus v is greater than 0, that means this quantity, this total quantity is negative. then what happens? Then d2 psi, the left hand side, d2 psi over dx square is less than 0. That means in the when in the region of in the region where psi s is greater than 0, in that region, using this you can say that in that region there will be maxima. That means the wave function will be like this, there will be a maxima. And in the below region, that means when in the region where psi of x is negative, that means in this region, right, in this region the wave functions look like what? There will be a minima. The wave function will look like this, there will be a minima. Okay, now is this actually justifying our actual wave functions? With our actual wave functions, let us go back to the example of square wave. We know that in square wave v is equals to 0 inside and v is equals to infinity outside. So v is equals to 0 here, that means e minus v is always greater than 0 here, right? So here this case happens, and we know this case happens means, okay, now using our previous knowledge of square wave potential, we know that the ground state energy of a square wave potential, suppose this is asymmetric square wave potential, that means this is 0, this is a, the ground state energy, ground state wave function looks like this, psi of x looks like this, and the fast excited state will be look like what? Fast excited state. Okay, fast excited state will be like this, like this. That means this is like this. Now let us justify this thing. We have discussed that above the plane, above the x-axis, the wave function will always have a maxima. Yes, that is correct. Here it is, here we have a maxima for the ground state, and for the fast excited state also. In the where in the region where psi of x is greater than 0, it have a maxima, right? So it is correct, it is fast excited state. And in the region where psi of x is negative, in this region, yes, there is a minima, and according to our theory here there is a minima, so it is correct. So yes, our general formalism is correct. So in this way you can justify that what you have drawn, the wave function, is correct or not. Okay, so I hope that you have understood the concept behind this video, and share this video with your friends, and for getting notifications of my upcoming videos, subscribe this channel and hit the bell icon. So take care of yourself. Thanks for watching.